Welcome to my talk, What Users Want. Oops, just a second. Yeah. First of all, let me introduce myself. My name is Vladimir Dejanovic. I'm the founder and leader of Amsterdam Java User Group, and as my day job, I'm chapter lead in development at ING. We would all like to have a crystal ball, right? So we could see the future and know what users want. Because then we could build exactly what they want and make fortune by doing so, right? Just imagine making Google or Facebook before Google or Facebook. You would be rich, right? But the fact of the life is that we don't have a crystal ball. So what do we do then? Well, the obvious thing is that we think that the users like the same things like us, right? We guess what they would like to do or what they would like to have. We use our gut feeling. We make assumptions. Assumption is the mother of all fuck-ups. Yeah. Sorry. Yeah. And basically, this was proven to me on more than one occasion, like in real life. So don't assume things. Know things. Whenever you assume something, it means that something will go wrong at one point of time. It is only the question at one point of time. Okay, but what should we do then? If we shouldn't assume things, how can we know actually what users want? Is there a better way to actually find out? Can we maybe ask them what they want? We are producing the huge amount of data nowadays, and all the time. Just think about how much data we create every day, especially through the social media. We are producing terabytes and terabytes and terabytes of data. It's huge, and its growth is only exponential. It's like it's going up. So why don't use all the data? Because in the end, data is power. And whoever has the data holds the keys to this enormous power. But of course, the first thing is that you have to actually gather this data. So monitor everything. Gather information about absolutely every single thing. Monitor how your users interact with your website, how users interact with your application. Know everything what is happening inside and outside your application before anybody else. Then, from this data, you create hypotheses. I think that if I do this, users will do that. Next step is to scientifically prove or disapprove your hypothesis. And in order to do so, you can use A/B testing. Imagine you have a website. And on the website, you have a green button. This is basically your base. And you think if you make a red button, users will interact more with your website. This is variant. So create the version with the red button. It's not that difficult. And then send traffic to both versions, A and B, at the same time, 50-50. Roughly 50% of the people will see version with the red button, and 50% of the people will see version with the green button. And then gather information. Monitor, look, what's happening? What are users doing? Are they interacting more with the version A or version B? Are they behaving in a way that you think they're behaving or not? Once you gather all this information, basically you have the winner. You will know what users want. You will scientifically prove or disapprove what works better, green button or the red button, or whatever you think of. Which means that there is no more endless boring meetings. I had my fair share of them, and I don't want them anymore. Also, no more he who shouts the loudest wins the argument. When you have no data, this is what happens. And then in the end, basically, who has the best stamina in saying for their point will win, which is not always the best thing, right? Also, no more hippos. Highest paid person opinion. We don't care how much you earn. If you earn more than me, it doesn't mean that your point is better. Show me the data. The data is the only thing that we should care about. Everyone has their own opinions, and everybody will be ready to fight for their opinions. But if you have a data, then there is no argument, there is no fight. Then you can just look at the data and see, okay, the data says this. All decisions should be data-driven. Amazon, Booking.com, Google, and many others are already using this and doing this for years to make their fortune. Why shouldn't we also do the same thing? Logic is the key. Logic and data. So use them. Don't use assumptions. Use data in making your decisions. Okay, so now that we know actually how to find out what users want, the logical question is, but how do we actually build one? What's the blueprint for actually building the A/B testing? In a nutshell, when users hit your website or your app, what you do is you need some mechanism basically to tell you, okay, should this user see version A or should this user see version B? Once you know it, you send him to the right version. Of course, the important part is that you need to monitor all of this. You need to know, okay, like, did the user see version A or see version B? The reason for that is because you want to save it and then use it later. If the user comes back again, you need to show him the same version. It doesn't make sense if you show it on the first attempt version A and then the next time you show him the version B. He'll think there is a bug in your system. So you need to make sure that you always send the same user to the same variant, and also you need to make sure to actually get information, did he behave in the way that you thought that he would do. So of course the first thing that you need to build is a mechanism like a flip of a coin, something that will on a rough estimate give you 50% chance for A and 50% chance for B, but it just needs to be roughly. It doesn't have to be perfect split. So basically what you want to do is to roughly split all your users into two buckets. Bucket for A and bucket for B. And this needs to be done for every single experiment. So if you have only one experiment on a page or in your app, then it's going to be like this. All the users will be in the bucket A or B. But if you have option for multiple experiments, then it will look something more like this. In this case, you have basically two experiments. And each 4 buckets has to have a roughly same number of users in them. Because if you don't split them evenly between the all 4 buckets, you will actually influence the data. You will influence how many users are going to see certain thing, how they're going to react, and then you're going to influence basically the data, and you will actually make your experiment invalid. And that's something that you don't want to do. Of course, if there's more than 2 if there's more than 2 experiments, like 3 or more, you just continue splitting every bucket in 2. A and B, and basically it ends up something like this. So depends how many experiments you have, that's many buckets you have to like split, and every bucket has to have roughly the same number of users. Like we said, we want also to make sure that the users always see the same experiment. So we don't want to pollute data like showing the same user experiment A and B, both variants. The simplest way for this is, of course, to store information in a cookie. You just put in a cookie for a user, okay, like you saw these experiments, for this experiment you saw A or B, and then you know it. And it's going to follow the user, of course, until he cleans the cookies. If you go with this approach, which is a very simple approach, at one point, if you have too many experiments, your cookie is going to be hit with the size of the cookie. You will not be able to store any more information there. So in that case, then you can think about actually transferring this information in the headers, or actually even better to use it in a server-side cookies. Because then in a cookie of a user, you would have like only some ID, and everything else will be processed in the background of your system. And then you can go nuts how many experiments you want to have. Okay, but how do we know if A or B is better? And how we even know if there is difference between them? How we can actually scientifically prove that? Well, luckily, math can help us there. What we need to do is first we need to actually see how many users see version A in total. Then we need to see how many users in total saw version B. And then we have these 2 numbers. We can then also know how many users in total were in experiment. Then we need to see, okay, how many users that saw version A converted or did what we thought it will do. And also how many of them didn't convert, didn't do what we thought they will do. And we need to do the same thing for B. How many people who saw version B converted, how many people who did see B didn't convert. When we have all these numbers, then we also know how many users in total converted and how many users in total didn't convert. This is a very simple thing together. Once we have this, we start crunching the numbers and doing the calculation. And the first calculation is that we need to calculate expectation. And expectation is for users that will see A and convert, it's calculated as total number of users that saw version A multiplied by total number of users that converted divided by total number of users that saw the experiment. In the case of what our expectation for users that will see A will not convert is, again, very simple. Total number of users that saw A multiplied by total number of users that didn't convert divided by total number of users. And similar is for B. Now when we have all of this, we have all our expectations, and then we can go to the next level. And the next level is basically introducing the G-test. G-test goes very simply as calculation 2 multiplied by measured number multiplied by logarithm of measured divided by expected. And that's why we need the expectations here. in case of one experiment who has variance A and B, it ends up something like this. Again, all of this isn't very high-tech math. It's very simple math. We can do very easily and calculate all of this, right? Then we use actually the value that we calculated for g-test as an input for the chi-square probability test. And basically, we will call the chi-square probability math function. We will give it two parameters, number 1, and our value which we calculate for g-test, and we will get g-square test probability. This value will be between 0 and 1. And then we finally can actually say if this actually made significant difference or not. We will use this probability that we calculated and put in very extremely difficult formula, just subtract from 1, basically, and we get the value. And in this case, what means if, for example, if we calculate 0.95, it means that actually our experiment has 95% chance that it's had significant difference. It only means that if we then look at the data and see A and B, and we see that, for example, B performed better, that means that 90% chance is that basically B is correct answer and is better. We can guarantee that with 90% of the chance. And that's it. Basically, that's all that is to it. Please don't forget to vote for the talk. Say what you mean, like is it good, is it bad, what should be improved or not. And luckily, I have 3 minutes for questions. So,
could you tell anything about your real-life examples? How did you do in your work those tests? What were the results? What you expected?
Well, basically, the main personal experience with A/B testing is inside Booking.com, and it's not really known that much outside of people who are really interested about A/B testing. But the Booking.com is one of the main, basically, companies which are like front runner in A/B testing. And exactly what I said, like first we started doing like with the cookies inside the browser, but we just because there was like millions and millions of experiments that were running all over the time. Basically, we hit the limit, and that's why then we moved back to the server-side cookies. And again, you can start with this, and again, the very good thing to doing this is with a small approach and just make it basic, and then adding more and more features to actual experiments. Because with the Booking.com, it ended up that you have like one basic criteria, then you have like additional 3 or 4 additional criteria that you were matching, and then there's some custom goals that you can really go nuts. And also, very good thing about this approach is that you can use exactly the same approach on a mobile phones, on a website, wherever. Basically, the 99% of application is exactly the same. Because basically, like the part with flipping the coin, it's the same part with actually collecting the data and crunching all the numbers, which you need to make sure that it's good, is the same. The only difference is basically actually how to do the A/B testing inside the application. So, for example, inside of mobile applications, it's very simple. You create 2 views, and then you say in controller, basically, kind of controller, show left or right, or actually hide this button, or I hide this button. In the front end, if you can do it on a server, you can then already do things in HTML. Or if you don't want to do it, if like there's some functionality which is happening inside the application, then of course it's in JavaScript. You can just say, okay, like go left or right.
And what was the business impact?
Well, business impact is.
Some examples of those tests, and you gather the data, give it to business. They decided that they would change something, and they made more bookings, or they made more.
Every single decision inside Booking.com was basically made according to the data and according to A/B testing. So that was one thing that they started doing very early, and because of that, they beat a lot of other companies which were at that time much bigger than them. And then that's the whole idea. Like, if you have a large amount of data, like for example Booking.com have, then you can say, okay, like I think this is correct, and you can find always the data that will like back you up. But then what you actually need to do is just create a test and just do the A/B testing on that one and say, okay, like let's see if it's really going to happen or not. And then just look at it and say, okay, like, if you see that, okay, there is like, will be difference or not. One thing that's also very important for everybody that I forgot to mention actually is you need to think about your users. Because, for example, in the case of Booking.com, it's very important for experiment to work at least for a whole week. Because people behave differently on a Monday, on Tuesday, on Wednesday during the weekend. Most people usually like make their bookings during the weekend. So if you put some experiment and it's like on Monday and Tuesday look like very good, and you say, okay, yeah, everything's good. It's like, let's push it to production fully. And then the weekend come and it can be completely different. So it's also, you need to think about seasonality of your users what they're going to do. But in case of booking, like every decision was, every time you have idea, put A/B testing, run it, see it, will it work or not. Good also thing about that one was basically that they have, like Booking has like billions and billions of users, so getting a lot of data is very easy because as soon as you put on a website, the millions of users will hit it right away. So, which makes it then tricky if you want to do A/B testing or some part of a feature which is not really seen that often, then sometimes you need to wait like for 3 months or 4 months or 6 months, and that's something that people don't like, but no problem. Yep, I think I'm off with time. Thank you.